happens, I'm wearing the same outfit as I was yesterday. No, just kidding. I'm just trying to record all these videos one after the next. Okay, so today we are going to be learning something a little bit new, but also using what we know about gases and ideal gases. So you maybe want to take take your brown sheet out because we're gonna write the formula for Dalton's law of partial pressure is like really simple, but you'll probably want to have it on your brown sheet, and it's okay to write it on there. You may want your stoichiometry flowchart. You'll also need your calculator. So if you did not bring your calculator, you may not go and get it. You need to come to class prepared. And so when it is work time, your sub may, if he or she so desires, allow you to go and get your calculator. But until then, just hang tight. You won't need it until after you're working on the problems. Okay, so today for Chem 1B, this is Thursday. So today on our Mexican vacation, we're going to this like pirate ship tour thingy. So like the tickets are really expensive. It's like $200 a person. And my mom gets free tickets because a couple of years ago when they were in Mexico doing this pirate ship thing, she is like super clumsy and like can't walk. That's where I get it from. And so she was like trying to like get herself onto the pirate ship, and she like grabs onto the railing, but like it's not the railing, it's like the edge of the ship. And right next to that ship is another ship, and the ships like bang together, and it like cuts her fingertip right off. And she like doesn't notice anything about it at first, and until like one of the pirates, like these like actors who are dressed as I don't know, like notices that there's a blue fingernail floating in the ocean. So they like have to whisk her off, and then she has to go to a Mexican hospital and have her fingertips surgically replaced. I keep like putting my finger up. It's her third finger on her left hand. That's why I'm not flipping off. And so now she gets like, because they feel so badly that she did this to herself, she gets like free tickets for this thing. So I don't know. So pray for me. Pray for me. So that's what, if you are in 1B, that's what we're doing on Thursday. On Friday, I think we just have a home day. So maybe I've never been to the ocean. So, except when I was in England, but I was like in high school. And, you don't really, like swimming in the Atlantic is not the same as swimming in the Pacific. So hopefully I'll be swimming in the ocean. So I hope that you are doing well and everything is going okay and you don't have any fingertips missing. Okay, so today's class is going to be about Dalton's law of partial pressure. It's not as complicated as it sounds. So I'm gonna write the formula down and you'll see what I mean. Okay, so let's say that we have a mixture of two gases. We're gonna call them gas A and gas B. Gas A has a pressure of its own. So like if gas A was just in the container by itself, he would have a pressure. So we call that pressure A for like the pressure of gas A. Let's say that gas A has a name. Let's say that it is hydrogen gas. So the way we would write pressure of hydrogen would be like capital P and then H2. Hopefully the video quality is decent enough that you can see this here. P and then little H2. The pressure for gas B is written the same. So it would just be P with like a B as a subscript. Let's say that let's say B is oxygen. So then we would write that as PO2. So each of these gases has its own pressure. If they were by themselves, they would have that pressure in the container only. So when you put them together in a mixture, because remember that gases are that word miscible. Do you remember what that word means? That's our fancy chemistry word that sounds almost exactly like the word mixable because it means the exact same thing. So when our gases are going to be combined in this container, all of the molecules of gas A are just going to intermingle all over with gas B. So the pressure of the total system is just going to be the pressure of A plus the pressure of B. And that's literally all there is to Dalton's law of partial pressures. The pressure of one gas plus the pressure of another gas is the total pressure of all the gases. This sounds like something that you should learn in like 3rd grade, right? It was actually a really big deal when scientists were first thinking about this, because gases were such an unknown thing. And in fact, like a lot of the really important physicists of the day and chemists of the day, like, so we're talking like back in the late 1700s, early 1800s, didn't know how gases worked and really thought that gases were some mysterious, like, ethereal substance. So pinning this down was actually really important, even though it seems like, okay, of all of the formulas we've used so far, this is like 1 + 2 = 3, and there's no catch. Like it's always 1 + 2 = 3. So at least there's that. Okay, so let's take a look at some of these problems so that we can practice using this like in a problem that you would get. Your sub will pass out to you homework 5.B. It's just a one sheet, just like your last one was. This one is due for 1B, it'll be due your next class, which is Tuesday. And then for 4A, it'll be your next class, which is, no, okay, I'm so sorry. 4A, you're due on Tuesday. 1B, you're due on Monday. So let's take a look at number 1. Again, when you're working these problems, there's I guess I don't know my colors. There's a green paper for you to check your answers with. Okie dokie. So let's take a look at question number 1. So it says oxygen and hydrogen are mixed in a container. If 1.45 atm of oxygen is placed in a container with a total pressure of 2.45 atm, what is the pressure of the hydrogen? Okay, so this is exactly the situation that we have here. So I'm just going to erase this, and with my orange marker, hopefully you can see it okay, I'm going to write what we have. We have oxygen and hydrogen, and those two mixed together give us our P total. Okay, so remember that hydrogen and oxygen are both diatomic elements. That means they don't exist. If you see hydrogen gas, that's not H, that's H2. So what that means is it'll be important for like calculating formula weight. There's some weird kids from another school who are poking in my window. I don't know what they want. They're probably band kids. Okay, so what do we have here? Let's write our data table down. We know that our pressure of oxygen is 1.45 atm. And then it tells me that my total pressure, not the pressure of the hydrogen, gotta read a little bit. It says with a total pressure of 2.45 atms, what is the pressure of H2? Okay, so if we are looking at our formula here, how are you going to solve this for pH2? That's what your unknown is. You're just going to subtract. It's really easy. So pH2 is equal to P total minus PO2. Now, if you did this backwards and you got a negative number, flip the sign because you can't have a negative pressure. So what should your answer be? It's really that easy. Okay, so now let's take a look at question number 2. Question number 2 says if 0.745 atm of carbon dioxide is mixed with 795 millimeters mercury of carbon monoxide, what is the total pressure of the container? Okay, so right away I see that I'm going to have to do a little more work this time because I don't have the same unit. But I can easily handle that by writing my table of knowns and unknowns down. So I'm going to erase this. Hope you're paying attention. Not sure which is the good marker. I think this is it. Okay, so it says that the pressure of carbon dioxide. So I'm going to write that down. It's really important to properly label these pressures because otherwise you'll have pressure this, pressure that, and you won't know what pressure is what. So that is 0.75 ATM. Oh, dang it, 0.745. Well, I did this problem wrong because I can't copy numbers. And then it says that the pressure of carbon monoxide, so PCO, is equal to 795 millimeters mercury. Yay! And then we're looking for our P total. I can't just add these. Why can't I just add these? Because we don't have the same unit. So you can either convert, oh, let's see if it asks. It doesn't specify if you want millimeters mercury or ATM, so you get to choose. Ouch. I'm going to convert this one to ATM. So how do we do that? The unit should go on the bottom of the next bracket. And then I'm going to look at my brown sheet, unless I have this memorized. And I know that it's 760. That number has to stay with this unit. I'm looking for ATM. So it'll just be 745 divided by 760. And I get 1.05. And that's in ATM. So now, I suppose I'm standing right in the way of myself. I'm just going to use this formula. Miss Bishop, do I have to write this formula down every time? I'm just adding things. You have to write it down. And the reason you have to write it down is because the number is actually useless to me. I don't care what the number is. I am teaching you how to procedurally do these things. I want you to know how to do it, not what the answer is. Oh, somebody, I hear a flute. And so I get 1.79 ATM. If you did this with the millimeters mercury, the answer you should get is 1361 mmHg. How many sig figs should you have? 3. Okay, so finish up copying this down. I'm going to take a drink of water. Let's skip ahead to number 4. In order to find pressure of individual things, you might need to use the ideal gas law like a bunch of times. That's okay. You know how to do that. So in number 4, let me just set that up for you. Okay, let's read this guy here. So there's no chemical equation, which means I'm probably not going to need stoichiometry, but it looks like there's a lot of stuff going on here. So let's take a read. Mixtures of helium and oxygen can be used in scuba diving tanks to help prevent the bends. The bends is this disease where if you go like underground or like you come up from being down below like too quickly, the nitrogen that's built up in your blood like naturally, like from breathing in atmospheric oxygen, can like wreck you. And so it's called the bends. So it says for a particular dive, 46 liters of helium at 25 degrees Celsius and 1 ATM. Okay, so that's a lot of information here about helium. Let's just start by getting some of this down here. I didn't give you a whole lot of paper. So definitely start on the very far left of your margin. Like so really close to the side of the paper, otherwise you'll run out of room. My bad. Okay, so I'm just copying this down. So I see 46 liters, and then I see 25 degrees Celsius. I know I can't use that, so I'm just going to convert that in my mind. So that's 298 kelvins. Then we have P. I'm checking the time here. It's 11 o'clock on Saturday morning, and I know that Carter's got his piano solo at 1:10. I really want to check that out. So that means I got 10 minutes to get this done in. So see if we can get her done. Okay, so we've got this. That's all for my helium. Underneath, I left a little space because I'm going to probably have to figure out N and R. O2, we've got 12 liters. And we're at that same temp of 298, and my pressure is 1. Okay, so what I need to do is figure out what the situation is with my gas tank. So I've got this much of my helium and this much of my oxygen. The deal here is that while we already are given a pressure, we can't just add these two pressures together because it says that we have this much of gas, but when it's confined to this size, this 46 liters. Our scuba tank, though, is not a 46 liter tank. 46 liters is a huge amount. So it says here, all of this gas is pumped into a tank of only 5 liters. So that's going to cause what to happen? So I'm not changing my temperature, and I'm not changing the number of moles that I have of my gas. It's like this same amount of gas, but I'm taking it from a really big space and putting it into a smaller space. What's going to happen to my pressure? It's going to go up, like kind of a lot. So what we need to do is figure out how that'll work. So in order to do this, we're going to need to solve for N here and here. That will give us the number of moles of each of our gases. I'm not going to do this for you. You know how to do the ideal gas law. You're fine. If you want to pause the video here so that you have a number for this, fine. Otherwise, you don't need to. Okay, so what we can do using Dalton's law is to calculate what's called the mole fraction. So X is the abbreviation that we use for mole fraction. Now, if you're afraid of fractions, you might not like this, but it's really not hard. So in order to find the mole fraction of a gas, you're going to find its number of moles and divide it by the total number of moles of the whole system. So it's like really like the percentage of like that gas that's in your container. So what you can do then is you'll know the mole fraction for both of the gases. Okay, so hang on to that right here. You're going to need that. Before we can calculate the partial pressure of each of the gases, we need to calculate the total pressure of our system. So we're going to do that here by like, I'll just write mixture here. All my variables. P is what we're solving for. So P is going to be our magical question mark. And we're going to want it in ATM. And the reason we do and we can't really choose in this case is because here you're using ATM. So it's probably best to keep all the units the same. What's the new volume of my mixture? Well, if I'm looking at my problem, my scuba tank is only 5 liters, so that's what I'm going to use here. N is the total of the mixture. So I'm going to add the N of HE plus the N of O2. excuse me, when you have an actual number for that, just go ahead and put those numbers in, it's fine. Oh, that is one janky too. Gosh. Okay, and then it says that at T is still the 298. Your problem doesn't really tell you that, but it doesn't tell you that it's at a different temperature, so we can assume that it's at 298. Solve your ideal gas law for P. This is the P of your total system. In order to calculate the P of each of your gases in this mixture, let's see, what color can we use now? Where's my blue at? Here we go. So the P of HE is equal to the mole fraction of HE times your P total. Why would you do this? So that you don't have to do the ideal gas law twice to find the two separate pressures. You only need to do it once and then multiply by the fraction. You certainly can do that. And in fact, on my green homework key, you'll see that I did that for this number 4. I did solve I did two separate gas laws and I added them together. You don't need to do that. You can use the mole fraction. So what you're going to want to do is write this down on your brown sheet, as well as Dalton's law of partial pressures, P of 8. Now you can use real gases, or you can use like PA, PB, whatever you want to do. It doesn't matter to me. You have to choose something though that you can make sense of. So if you write it on your brown sheet and it doesn't make sense to you, you can't use it when the exam comes, you're going to be sad. So make sure that you spell that out clearly for yourself. Okay, so number 5, you're going to need to calculate formula weight for everything. And then the rest of them are really pretty, you shouldn't have a problem. Number 8, you will need to use this formula. So make sure that you do that. You have the rest of the time to work today. You should be able to finish this entire assignment by the end of class today. Hopefully you started your Silas timer. I forgot to remind you. I'll leave a note for your sub in case you want to do that. Just try to beat AP Chem. This is due to the homework tray at your next class. So if you don't get it done today in class, you'll have some homework. Sorry, but you should be able to do this in class. Okay, I hope you guys are having a good day and that everything is going well. If you have questions or if you're like, oh, I'm not getting this, watch this video again. It's posted on Google Classroom. Watch it again at home. Slow it down if you want to. Go back over the examples, and you should be fine. All right, I got 2 minutes to get down to the auditorium to see Carter's piano solo. Do you think I can make it? All right, hopefully I can. See you guys soon. Love you. Be good. Bye.